Hi everyone and welcome to Fusion 360 Monthly Challenge 2018. Joining the challenge is very easy. All you have to do is forward your full name, school or company name together with your Fusion 360 email to autodeskcommunityphilippines@gmail.com. Let's start off by creating our base. And to make things interesting, let's make this as a sheet metal. Let's create a new component. I can go here to create a new component, right click on this unsaved file, and on our canvas I can also right click and select new component. Let's name this component as base. So left click and left click once more, typing base, hitting enter. Let's change our workspace by heading to Model and selecting Sheet Metal. Let's create our sketch. So I'm going to hit L for line and let's sketch on our YZ plane. So selecting this plane, left click. Let's drop our first point here at the origin. Moving up and let's key in 103.03 and hitting enter. Zooming out, hitting L once more for a line. Let's create a horizontal line. Key in 60, hit L once more, create a line. Let's key in 51.82. L once more, create a line here, left click, hit escape, hit D for dimension. Let's select this line and this horizontal line. The angle to be 135 and this line to have a dimension of 50. With our sketch fully constrained, I'm going to hit escape and select stop sketch. Before we turn this into a flange, let's first define the thickness of our sheet metal. So let's head to Modify, select Sheet Metal Rules. Let's make this as a steel. So selecting New Rule. Thickness to be 5 millimeters. Let's leave the rest to be at their defaults. And let's name this as 5 mm. Hitting save. So here's our new rule and selecting close. Let's now select flange under create and let's select this profile, making sure chaining is enabled. So selecting this lines. And for direction, let's change this to symmetric. Let's pull this arrow. And under distance, let's be exact by keying in 25. In addition, making sure that the thickness on the side goes out. So the inner one is our sketch and the thickness is protruding out. Selecting OK. Let's check the thickness of our sheet metal. So selecting this edge. So it's currently set at 2.5. To apply to the new rule we have created, let's simply expand our base, select switch rule, and select 5 mm. Hitting OK. New thickness applied. Let's apply the hole here, and instead of using the hole command, I prefer sketching. So let's select this face, hit C for circle. Create a circle here. Diameter to be 10.5. Hitting enter. Let's head to our constraints and grab our horizontal vertical constraint. Select our origin and the center point of our circle. Hit D for dimension. Let's select this edge and our center point. Place our dimension here. Key in 39.14. Selecting stop sketch. Let's also sketch on this face. Selecting this face, hitting C. Drop our circle, key in 10.5. grabbing our horizontal vertical constraint, selecting our origin and our center point, hit D for dimension, selecting this edge and our center point, key in 25. Selecting stop sketch, and let's now hit E for extrude, select the circular profile, change my extent to object, left click our arrow and left click this face, operation definitely cut, hitting OK. Repeating extrude, hitting E, selecting this profile, changing the extent to object, left click our arrow and left click this face, hitting OK. With our parent component complete, let's now apply the best practice of grounding our parent component. So right click on base and select ground. Let's create the next easiest component, which is the box-like figure. Heading to Untitled or our main file, right click, select new component, and let's rename this as Spider. Our base is currently a distraction, so let's isolate our spider component. Heading to our component, right click, and at the bottom, which is not covered by our screen recorder, is isolate. With our spider component active, let's now enter sketch mode. So I'm going to hit R to grab our rectangle, and let's sketch on our XZ plane. And under feature options, let's change our rectangle to center rectangle, dropping our center point at the origin. With the dimension field currently highlighted in blue, which is now at 75.617, I'm going to key in 20 and hit enter. Delete this dimension. Head to constraints and select equal, selecting this horizontal line and our vertical line. Hitting escape. And let's now hit E for extrude, selecting this square. Let's change the direction to symmetric and operation to be new body. The whole length will also be 20. And hit OK. Let's create the 4 holes. So hitting C for circle. And let's sketch on our XY plane. So notice as I hover over my target plane, a face is currently highlighted. To select nested items, I can simply left click and hold, then a drop down will appear. So selecting XY plane, create a circle at the center or at the origin. Diameter to be 10. Hit E for extrude, selecting the circular profile. So once more, left click and hold, selecting profile. Let's change the direction to 2 sides, and under extent, let's select all and hit OK. Repeating the procedure, hitting C for circle. Let's now sketch on our YZ plane. Left click and hold, selecting YZ. Keying in 10, hitting enter, hitting E for extrude, selecting the circular profile, left click and hold, selecting profile. Under direction, selecting 2 sides, distance to be all. Same with side 2 to be all, hitting OK. Moving forward, let's create the lever pin. Let's turn off the visibility of our spider. Create a new component, naming this to pin-lever. Activating our new component. Let's hit C for circle, and let's sketch on our XZ plane, dropping our center point at the origin and keying in 10. and hitting E for extrude, selecting our circular profile. Under direction, let's select symmetric, pulling our arrow up and changing the operation to new body. Measurement to be whole length, and let's key in 20 for distance. Selecting OK. Let's create another sketch, selecting the top face, hitting L for line. Let's create a vertical line from here going here. Hit escape, reselect this newly created line, right click and select horizontal vertical. Next, hit D for dimension, selecting our origin and this vertical line. The value to be 1. Let's now hit E for extrude, selecting this profile, pulling our arrow down. And for the distance, let's key in -5. Selecting OK. Next, let's add a thread on our pin lever. Hitting S for shortcuts and typing TH. Selecting thread. Let's select this face and disable full length. Let's pull this arrow down and key in for the length 5. And let's have this modeled. Take note that making modeled threads increases file size, so keep that in mind. Selecting OK. Let's add fillets on these sharp corners, creating a window selection. So under select, making sure window selection is enabled. Create a window selection, release. So once again, I forgot to hit F. Hit F for fillet, create a window selection. And for the radius, let's key in 0.5. Selecting OK. Next, let's create the yoke. Let's turn off the visibility of our pin lever and head to our main file, right click, select new component. Let's name this as yoke. Activating yoke. Let's start sketching, hitting C for circle, and let's sketch on our XZ plane. Diameter for the circle is 40. So keying in for T. Let's now hit E for extrude, selecting our profile. Let's pull this up and change the operation to new body. The height of our cylinder to be 60 millimeters. Selecting OK. Let's change our workspace back to model and hit S for shortcuts, typing SH. Selecting shell. Let's select this face, and for the inside thickness, let's key in 3 and hit OK. Next, let's create the 2 holes on our hollow cylinder. So hitting C for circle, let's sketch on our YZ plane. Drop our center point here and key in 10. Hitting enter, grabbing our constraints, specifically horizontal, vertical, select our origin and our center point. Hit D for dimension, selecting our center point and this bottom edge. Dimension to be 50, hitting enter. Hit E for extrude, selecting our circular profile. Change the direction to 2 sides, and under extent, let's select all. Same for side 2, all, and hit OK. Let's create another cut extrusion. Let's grab our rectangle, hitting R, and let's sketch on our YZ plane. Create a rectangle from here going here. Next, let's create a line from our origin going up, hitting escape. Let's make this as a construction line. Let's now hit D for dimension. Let's select this vertical line and this vertical line. Key in 10. Selecting this horizontal line and this horizontal edge. Key in 30. The diameter of our cylinder is 40, so let's select this vertical line and this vertical line. Key in 10. Let's now hit E for extrude, selecting this rectangle, changing the direction to 2 sides. Operation, cut, extent, all, extent, all. Selecting OK. And let's hit S for our shortcuts, typing MI. Let's mirror this cut extrusion. So the pattern type to be feature. Let's select this extrusion, activating mirror plane. Let's mirror this using our XY plane and hit OK. Next, let's add fillets to our sharp edges. So hitting F for fillet, selecting this edge, this edge, this edge, this edge, this edge, and finally this edge. Let's key in 5. Looks nice. Selecting OK. In addition, let's create a hole at our bottom face. Selecting this face, hitting C for circle. Create a 10 millimeter circle. Hit E for extrude. Pulling this up. Let's change the extent to all. Selecting OK. And in addition, let's add a thread. So hitting S, typing TH, selecting thread, selecting this face, select modeled, and enable the defaults. Selecting OK. Let's activate our main assembly. And right click, select Unisolate All. And turning on the visibility of our spider and pin lever. Let's apply joints. So heading up to assemble and selecting joint. Let's connect our yoke to our basis hole. So heading to our yoke. But first, I'm going to hit cancel and move this here. Hit J, which is the shortcut for joint. Now, whenever this dialog box appears, simply select capture position. So hovering over this face, holding control to lock down, center joint origin, left click, moving over to this face, holding control and selecting this center joint origin. Now the appropriate motion type should be revolute. Selecting OK. Moving forward, let's assemble our spider to our yoke. Grabbing our spider, moving it here. Let's hit J to grab our joint and selecting capture position. For component 1, let's head to our spider. Hover over this face, hold control, and select this center joint origin. Next, we need a joint origin here. Now the problem is between two faces. Once again, if I right click, between two faces is not applicable at this moment. In this scenario, we need a joint origin. So I'm going to hit cancel and activate our yoke. We need a reference to place our joint origin here at the center. Let's grab our existing sketch, which is sketch 2. From here, I can type S or head to assemble and select joint origin. Once more, selecting capture position, type simple, and let's select the center point of this sketch and selecting OK. Turning off the visibility of sketch 2 and activating our main assembly. Let's grab our joint once more, hitting J, hovering over this face, holding control and selecting this joint origin. And for component 2, our joint origin. Selecting OK. Next, let's create another instance of our yoke. So selecting our yoke, hitting Control C, left click anywhere on the canvas, Control V to paste, selecting OK. Select our new instance of yoke, left click and drag. Expand our yoke and turn on the visibility of joint origin. Let's now hit J for joint, selecting capture position. Let's hover over this cylindrical face, hold Control and select this joint origin and this joint origin. Selecting OK. So notice the effect of the joints combined. Next, let's insert our pin lever inside the hole of our base. And before I hit J for joint, I want to make sure that if I hover over this face, I am selecting the center joint origin, which is here. We will be making revision to our pin lever, so let's activate our component and head to thread, right click and select suppress features. Double left click to zoom extents. So here's our pin lever. Let's move this here and hit S for model shortcuts, typing JO, selecting joint origin and capture position. Let's hover over this face, left click on the center joint origin, and if I move this up, notice here we have a value. Now here I prefer linking a parameter. So let's select cancel, head to modify and select change parameter. Now under our pin lever, recall when we created the thread, we have a thread length of 5 millimeters. And the name of that parameter is D49. So take note, D49, selecting OK. Let's now grab our joint origin, capture position, selecting this joint origin, move this arrow up and key in negative D49. So it's always the same as our thread parameter. Selecting OK. Moving back to our thread, right click and select unsuppress features. Let's now grab our joint origin, but first let's activate the whole assembly. Hit J for joint origin, selecting our newly created joint origin. Hover over the base's face, hold Control and selecting the center joint origin. Motion type to be revolute, and let's flip this, selecting OK. Our next intent is to apply a rigid joint on our pin lever and this yoke. To make things more interesting, the base and the yoke doesn't match perfectly. To demonstrate, let me hide our base and turn on the joint origin of our pin lever, hitting J for joint, selecting capture position, selecting our joint origin, hovering over the face of our yoke, holding Control and selecting this joint origin. Selecting OK. So notice we have a warning. The challenge is I want you to reconfigure the base to fit the yoke perfectly. The rest of the parts, such as spider, pin lever, and the yoke will remain the same. In addition, the exercise file for this activity is available via download link in the description below. With LinkedIn Learning as our sponsor, we will give out 50 3 months LinkedIn Premium and LinkedIn Learning subscription to first 50 monthly challenge participants who can forward the corrected base. Email your files or download links from A360 to Autodesk Community Philippines at gmail.com. Once more, happy holidays and Merry Christmas to everyone. And see you in the next Fusion 360 monthly challenge.